I got it.
Okay.
You got it.
The stage is all yours.
I got it.
Yeah.
Do you have like a Jupyter notebook? Can you see that?
We
Yes,
can
we
see
can
you.
see. We
Yeah,
can
we can
see.
see the slide, the Jupyter notebook.
Okay. So as I mentioned, you know, like today we are discussing about dealing with the class imbalance. Later on, I will send this presentation into Jupyter Notebook to Ray so he can also share with you guys. So as I mentioned, imagine that you are dealing with, you would like to design a kind of neural network or whatever learning algorithm that want to predict or diagnose if this patient having the specific rare disease or not. So as it coming at is clear from a disease name, it's a kind of rare disease, and it's not common, fortunately, that many people have this. So then naturally, what is happening here is that we are having access to a big amount of a normal sample, which means that by normal here is that the patient who do not have this disease, and very, very few samples that patient have this disease. So that would be a problem for learning, for designing a learning algorithm to be able to predict or diagnose this specific disease by this specific disease in terms of the data that we have in our hand. So it means that if assume that in this case you're having like kind of X-ray image or whatever image type, and then the number of the image that you have for a normal patient is higher than the patient that you have for a patient who specifically has this disease, right? So for this task, we have been focused on the data set. It's like the name of the data set is a malaria data set, I believe that Raisi introduced it to me. So I think you already from the previous session, you have this data set anyway. This data set consists of two.
Sadegh, forgive me for interrupting. Can you make your font size bigger by just doing a zoom on this window? I think if control scroll wheel will do it.
Like this? Yeah. So for this tutorial, we are working, as I said, I mean, like from the Jupyter notebook that I see from previous session of this class, it was on TensorFlow. However, I'm PyTorch user, so but please do not be worried about the type of framework that we are using, PyTorch or TensorFlow. You're doing at the end the same task, but please be focused on the concept here. Anyway, so what I did, I create, so we import kind of the torch or necessary packages for this tutorial. So basically what we did, I just simply import torch, the pandas that we need. I wrote also the requirement that we need. So we basically need a PyTorch 1.81 and 1 AI pandas and seaborn. So seaborn. So what we did here in this part of the tutorial, I load the data that consists of around 14,000 images, the healthy cell and unhealthy cell, which is divided into two different classes. Like I call this one is infected and uninfected, so normal and non-normal. So however, like what I did here is just a pre-processing step, because I want, as the original data set was kind of a balanced data set, 40,000 from infected class and 14,000 from uninfected class. I wanted to simulate the scenario that we have imbalanced data set, such that the ratio between uninfected and infected are 100 samples. So basically what I did, I I extract a kind of sample from this data set. So 1,000, the ratio is between like 1,000 to 100. And what I did basically, I plot this distribution of the data, and you can see that the distribution is huge. You have 1,000 samples from an infected cell, and only 100 samples from the infected cells. So this is equal to terminology that I said that we are dealing with a kind of rare disease that we are having a lot of samples from a healthy patient, while we are having at the same time very small portion compared to the healthy samples, like around 100. So it's like there is a huge class imbalance between them. And why this is important? So once you are training your model with a huge class imbalance, the learning algorithm has this capability to see more sample 10 times more compared to, in this case, 10 times more compared to the other class. So the majority class see one sample 10 times more than minority class. So this bring a kind of a bias toward an infected class, which would be, which we call it bias. It's basically the model would be very good on predicting an infected class or majority class, but while at the same time would be very bad on minority class, because basically it has lower opportunity to be exposed to the class where it is a minority, right? So that's what would happen at the end. Our model is able only to predict most of the time an infected or majority class, which we cannot really make any diagnosis or decision based on the output that the model proposed us during the validation or during testing. So we need to remedy this problem by a kind of technique that we call it oversampling. We also have other methodologies which I would like to give it to you to do as a kind of a small assignment to see that, you know, apart from oversampling, what kind of other approach exists for next session maybe. So yeah, this one that doesn't work, yeah, of course, because we need to load the import everything to the Jupyter notebook, and then we run that. So by this part of the code, what it does is basically it goes through the original data set that we have. It loads them everything in a pandas data frame, and at the end we get kind of select a subset of that. So basically what you have as the output of this cell is nothing but, let's see, is nothing but yeah, ignore these two column, the first column, nothing but the name of an image and basically the name of a folder that the image is saved in, and the label that I give it to this class, which is basically means that infected, parasitized, the scientific name of that. And if we look at, for example, the tail of this data frame, it basically means uninfected, and the associated label to this uninfected class is 0. The reason that they transfer it in data frame is basically it's very easy and handy to play after that with the data. So I like this approach more than the playing with the list of array or something like that, because it makes some effort to create that, but then after that it pays off. So you can play really good with that. And then here we I create basically the kind of bar plot to just show you the class imbalance resulting from the artificial data that I created in this in the previous stage. So a step. So yeah, maybe I can run that. Yes, it's running smoothly. And but then you need to feed this data set inside your data frame. This step that I presented to you from now on is exactly the same as a data frame as a TF record, for example, in a TensorFlow, but then for PyTorch is a little bit different. So what you need to do is basically you create a list of dictionary in order to be able to fit it to the PyTorch. So what I do here, I write a small function, and you can see that what would be the output of this function. So like, let's say data 0, and basically it's nothing but a list of a dictionary, which I only get the first element of this list, which is basically a dictionary, and then the name, image, and this is a directory of full path of the image that we would like to give it to the model, and the label which is associated with this image. And then after that, you need to do kind of a transformation, which I believe Grayscale discussed about the data augmentation in a previous tutorial. So what we need to do is that first, well, this is ensure. I mean, this is a detail. I do not go to a detail of that. But then what we do is that we load the image in this data transform. We ensure that the channel, because we have like the size of image 200 by 200, and for example by 3 channel. It's this framework. It works. Yes.
Can you hear me? Yes.
Yes,
So
sure.
there is a question. I think Greg answered it, but I think also you need to give more detail about it. What is the MonAI?
MonAI is basically kind of a package which is based on the PyTorch, and it's very much, if you work on medical imaging, it's very much recommended to use that, because it has a lot of predefined, it provides a lot of predefined tools to work with the 3D images and 2D images. So you can see that, I mean, like basically you can feed the data in there and apply this transformation with a few lines of code. No, so this is basically is nothing but a package. But I would say that, you know, is if you want to know more about that, it's good to look at the MonAI project, King College London or NVIDIA. You will get a whole project page, and it's like a lot of tutorial in there. But if you have like a further question after that and you want to know more about that, please write me, then I can also give you further information. But I would say that this is a package. It specifically empower you with a lot of built-in function that you can play a lot with 3D imaging. However, you can also use this transformation also for 2D imaging. So in this case, I use this one because it's very much handy for me to use that. So yeah. Is there any question? Yeah. So, but what MonAI is doing basically is defining, yeah, all these packages. So all these tools, which you basically you give the image, which is coming from this data list of the data, and it reads, you know, it gets the key of a dictionary, which is image here. It loads the image. It ensures that the size of the image is a channel, which is a 3 by 200 by 200 by 200, the size of the image. It resizes the image. It sometimes in your folder you have the image which are saved with the different lengths and heights. It just resizes them. I resize them with the 224 by 224. We random flip out some images with the probability of 50%. We rotate them with the like 90-degree with a probability of a 50%, and we add noise, and also we convert them to the kind of, we call that tensor, which is a format which is readable for TensorFlow after that. So where it goes, this transformation, it goes to the kind of, for whole this stage is just make the data ready for a PyTorch. It goes, you only need 2 lines of code to be able to create a data set in a PyTorch. After you pass through this step, you put the data that you created here in the previous stage. It's a list of a dictionary. This data transfer that you have it here, which apply all this transformation on the top of your data. And then then you need to create a batch of data. So basically what it does, you get this output of this from this function, and then you just basically give it to this to the other function, which create create a stack of your data with the predefined with the specified batch size. The batch size, what does it mean? It means that if you have 1 million sample, you cannot really fit 1 million sample at once to your machine. So what would happen here is that you get a lack of memory, and you cannot really proceed that. The common exercise once you are working with a neural network is that you get these 1 million sample, you divide them to the small pieces, let's say 100, 100, 100, and 100, for example. In this case, I set it to 10, right? So in each time, you divide your big sample that you have, like let's say 1 million, to the batch, we call it batch, to a batch of 10 by 10 and 10. So it's like going to be, I don't know, 10,000 of 10 would be, for example, 1 million, and then like 100,000 of 10 times of a batch would be 1 million. Then you would not get a memory issue. But the ideal case would be, you give all your 1 million images to the machine, but unfortunately, with one GPU, you could never do that. So, and what does it mean by class imbalance? If you are like, we create this data, and then you can see that if I run this model, what we get, and then here. So look at this batch of, I create now the batch. As you see, we have 1,000, we have 1,000 image for uninfected, which are class 0. We name it by label 0, and then we have only like 100 samples for class infected, or the patient who are infected by this disease. So I just run the kind of sample, like some sample test to just show you what is happening. In each batch, mostly you have like 9 samples from a majority class, for example, and then only 1 sample from minority class. For this one, you have all of your sample that you created is coming from majority class. And you can see that the distribution of the data that we have. So the problem that you can see here is that mostly during training your model experiencing the majority class much more than minority class. So there is we call that class imbalance. So it's quite obvious that this problem exists. So for example, here 10 times it's just looking at there is no minority like a minority class that you could see here, right? So to solve this problem, we need to apply weighted sampler in PyTorch, or we call it like a oversampling. So it's only like a 3 lines of code. We have like a 3 step to deal with that. So in the first step, what you need to do here is that basically, let me run that step by step to show you what is happening here. So we have here class sample account. What it does with this step one is that it just gets the distribution of the data. So the class sample that we have for an infected and infected one is 1,100. And then in step two, what you do is basically you compute the inverse class sample, which is nothing but 1 over 1,000. So we just put these two side by side so you could see the difference between them. You could see that 1,100, and then in next step, what it does is that we divide 1 over the class sample that we have here. It would be 1 over 1,000. And then in step 3, what we need to do for whatever sample that we have in our data set, we need to create kind of a probability map, which is a requirement of a sample weight class. So you see that what is happening here, sample weight, and then what it does, basically for each number of a sample that we have, it creates, and I put maybe the length of that sample weight, and then I do like this. So in total, okay, this we create a class. We create a class count. We create the inverse of a class count, which we call that the weight, and then we assign each of these probability that we created, or 0.001 and 0.01 to each sample that we have inside our whole data set. So minority class, normally they get like a 0.01, and the majority class they get like 0.001. So what it means is that the minority class, they have a more probability to be like appear in oversampling compared to the minority class. And we feed this at the end to this. The magic would happen here that we feed this to this function, the weight that we calculated. So let's see in practice what is happening if we apply that. So compared to what we've seen here, maybe I copy paste that one in a down part. So you could see here, the number of a sample now we have in each batch is 6 to 4, and in previously it was 9 to 1. 4 to 6, it previously was, for example, 10 to 0. And you see that although they are not one by one comparable, because once you apply this function one more time, what is happening here is that they are using different sampling strategy. However, they are not one by one comparable, but you could see that mostly what we have in each batch of the data, they are balanced. There exists like a much more much less class imbalance compared to the previous approach. So having this data ready, in the next stage, what we could do is we feed it to our neural network model, and we train the model by that. So this is about like a class imbalance in class oversampling in overall. So do we have any questions?
Hey,
Guys, any questions?
Yes, Greg, please go ahead.
Could you go back to the weight and probability again? Like I didn't catch how you were able to increase the probability for the prioritized label.
So here, for example, okay. First of all, what everything is done. So where this class? Okay, it's here. So as a requirement, okay, there is in PyTorch there is one function which is as a requirement. It takes basically the sample weight and length of a whole sample that we have here. By sample weight, what it means is that basically we need to assign for each sample in our data set a probability, right? A probability of a majority class in this scenario has to be less than minority class, right? So if, for example, the ratio between, you can see here, for example, in the class count, I don't know when I highlight, you could see it or no. So you could see it, right? It was like 1,000 to 100, right? And then we compute the inverse of a probability, which is 1 over 1,000. It means that 10 power of minus 3, right? Which is less than the minority class, right? So what is happening here is that for each sample which we have like a majority class, we get a lower probability. We assign this probability to a lower probability to a major class, right? To a major class, and higher probability to a minority class, right? So once you give this probability to this weighted random sampler, that does the magic part, that somehow it just creates a kind of batch which are mostly which are mainly what they balance. They are balanced, right? So these are the requirements that we only do to just provide what this function asks from us, and that's the way to create that. So basically, get the occurrence of a sample, create the inverse of occurrence, and then assign it one by one to each sample that you have in your data set, and then you would have a kind of like a balanced batch of a data.
Thank you.
You're welcome.
Okay, any other question, please? Right now, I think, Sadegh, we will stop here for the oversampling. And other techniques, it will be, what is your suggestion assignment first?
So as a suggestion is that please, for whoever would like to work on like having like a kind of practical examples, play with the batch size and play with this part, which is the number of a sample that you have, to see that the impact of oversampling, that how the distribution of the data will change for you. And at the same time, what other technique exists to solve this problem? This is not the only technique to solve this oversampling problem. What other techniques we could use to also solve this problem without changing the number of samples within each batch? We have oversampling and other approaches. So whoever are interested to go through the theoretical part, they could take the second one. Whoever would like to work on a hands-on programming, they could go with the first assignment, which basically playing a little bit with code, playing with the number of samples to see that, you know, how the distribution of the data would change if they run the code. You do not need any computational power for that. It's like I'm running on my normal PC. So, I mean, don't be afraid of that you do not have a computation. The only thing that you need to do is that to install PyTorch if you want to use PyTorch, and if you want to use my code. So that's the only requirement that you need.
In class, this is where we want to strive to be more together. As in our pipeline class chat on Slack, as you discover techniques, please list them in there to save each other time. So one of you is going to come across, I don't know, maybe something called SMOTE, S-M-O-T-E, and you'll maybe write up something on that, or we'll try to, Sadegh, I'm assuming we can take this code, we can take this notebook, and they can modify it. So you guys can modify it with different tools, right? And then I should be looking here. Y'all are right there. And then share that with the class in the pipeline class chat on our Slack. That would be just, you know, I have a shop out here and it's messy, but there's a lot of tools in it. And I love that there's tools out there. Well, we don't always use all those tools. They're somewhere stored in a shelf, but we want to keep more tools handy, because what Sadegh has shared with us today is a common problem, especially in the medical field, right, Guy? Where we have imbalanced sample sets a lot. Okay, probably I'm thinking we should go to Hitesh for the amount of time we have left.
Yes, I think yes, it will be great.
Oh, and thank you, Sadegh. I feel, thank you, everyone.
No,
Hey, thank you.
you're very welcome. Thank you.
All right, Hitesh, you ready? I think Gaith is giving you control.
No,
Yes, Tom.
You are the host right now. You can give him the control.
Oh, very good.
Make him go co-host.
Let's see, spotlight from Hitesh. Oh, I don't. Okay, I've never done this in Zoom before.
Okay, I have the control setting.
Oh, excellent.
Yeah, is it visible?
Yes, it's visible.
Yeah. So the assignment was to rotate any image by some arbitrary angle that we want. The TensorFlow only provides us function for rotating image by 90 degrees. And so we are going to use affine warping. That is the basic concept behind this thing. So we'll use this image here of the Avengers, just because I'm Avengers fan. Sorry. Yeah, so the main problem that occurs when we try to rotate any image by some angle is that the edges get lost, you see. In the above image, you see the edge of the frame and Thanos's head has some gap. But when we do it here without frame adjustments, which I'll show you in a moment, you see the Thanos's head has been cut here. That is the problem here. So what we will do is we will have some frame adjustments, which has been done in this function. Yeah. So after we adjust the frames, you see, this is what we get. So the frame is like the size of the frame has been increased just to accommodate all of the stuff in the image here. Just to explain.
I want to ask you.
Oh no.
Why you stop the sharing? I want to ask how you determine the size of the new frame.
Yeah. My browser just closed abruptly. Just a minute. The size of the image is determined by the new height. So when we first rotate the image, and then we determine the new size of the frame. Yeah, using the new height and the new width of the image. You can look for the maths behind this thing on the internet, and there is a very good book written by Dr. Richard Feynman, 6 Not So Easy Pieces. In that he explains this very beautifully, the math behind rotating frames, although it is for a different purpose in that book, but the explanation is very good there. So Zoom and Colab are not good friends.
Okay, one more question. I want to answer. I think you have something about Colab 5. It's about the 6th question in the assignment about RGB to RGB.
Yes. So for the second question, I have this Word file here. So when we convert from RGB to grayscale, we convert the color channel of the image from 3 color channel to one color channel. Is my screen visible?
Yes, screen is clear. Continue.
Yeah. So that is what we do. So it's like taking a vector in 3 dimensions and projecting it on 1 dimension. That is what we are doing basically when we are converting RGB to grayscale. So now the question is, how can we convert it from this one-dimensional vector to three-dimensional? Yeah, that is how we will be able to convert grayscale to RGB. So if you say this is the standard method that we use, the TensorFlow and OpenCV libraries use to convert color images into grayscale. But if we just have the information about grayscale, we have no way of knowing the red and the green and the blue values for pixels. So functions don't do that, you know. They map one-to-one in values. So it is not possible, according to me, now what I have researched, to convert RGB into grayscale into RGB, like to move it back in time.
Okay. I'll accept your answer right now. I have some comment, but first I think Jonathan wants to ask something and he wasn't able to raise his hand. So Jonathan, please.
Yeah.
Yeah. So great that we was able to rotate it, but I want to come back on the first comment that you mentioned, that you said in TensorFlow, but you're not able to. Yes, we can in TensorFlow rotate, but I just wanted to know if you're able to data mine the resized image again in TensorFlow, and if you can, maybe we can get together just to understand how to resize the image in TensorFlow, because I was able to rotate the image in there.
Okay, so rotating and resizing it to the original image we had. Is that your question?
So the question is if, because the first point is that you said we wasn't able to in TensorFlow, which we can do.
No. That is not what I wanted to say.
Yeah, but then if you can, my point, so you've used CV, I'd be very interested how we can data mine the new frame within TensorFlow, just so I can see both sides, like, so we get the full tools being used.
Okay, so instead of using OpenCV, we use TensorFlow. That is the thing, if I'm not wrong.
No, so first one you said, sorry, just to go back, to clear my confusion, the first thing you said was that you can't rotate other than 90 degrees in TensorFlow.
Yes.
Right,
Yes.
You can rotate other than 90 degrees in TensorFlow. But
okay.
What I would like to find out is how, using both CV and TensorFlow, how to data mine the new frame.
Okay, I'm not quite familiar with the TensorFlow because I haven't used it much. I have used OpenCV, so that is what I've used to do the task. So I'm sorry, I cannot give you any way of doing it in TensorFlow.
Okay, but great to be able to understand it later on in OpenCV, so we have the both tools available to us.
Yeah.
Any question from anyone?
Yeah.
Hitesh, could you go back to the code where you were kind of like setting up I think you were setting up some sort of coordinate to kind of capture the edge to make the rotation? I'd like to see that.
If
it's still crashing. Okay, no problem.
Yeah, it's crashing. That's the problem. So the basic thing is the image goes out of a frame. So imagine a wall which has a safe door, and we have a painting just to cover that safe door. Yeah, and if we rotate the painting or the image, if we rotate it, we can see the safe door. Yeah, it goes out of the frame. That's what happens, and that's why the edges of the image are missing. So just to accommodate those edges, we have to resize the frame. So that's why we have this function. And you see these two lines, they give us the new height and the new width of the rotated image. Here, these two lines. Okay. And This is, there's a new height and new width. Okay, so here we have a new height and new width of our image that after rotating that we've got.
Is there some sort of like zoom function too? It's kind of like you could rotate and zoom out.
Yes.
Yeah.
Yes. Yeah. No, we cannot zoom out, but we can zoom in.
Okay.
You see this one here. It's a scalar that is multiplied to the cosine of the angle that we want to rotate by. So if you 2 or 3 or 5, it zooms in. But if you have, say, like negative, I tried it. I tried adding negative, so it would zoom out, but it won't. It just rotates by negative angle. So if yeah,
even if the value is less than 1, like 0.2.
Yeah.
Okay.
Yes, it will just zoom in.
Okay.
Yeah.
Thank you.
Zoom out. Yeah. Thank you.
That's great.
By the way, Greg, thank you, Hitch, first. It's good presentation. I have a comment, but I want to keep this question open, the Grayscale to RGB for the next week. Maybe we have all of us to make more research about that. I have a comment and I can give you what I'm thinking about.
Yeah.
And by the way, I found that there is some researchers also, it's happened and there is tools appeared. Yes, Jonathan.
Yeah, so I did actually post my findings in the pipeline class chat as well on the Grayscale. So I did ask if anyone else would like to come and share. I invited more people to come and comment on it as well. So it's there if you want to participate with me.
Yes, of course.
So it's already there in the class chat under Guy's thread. It's in there. So I've put what I found out in there. So maybe when we come together, we'll get quite a nice reasoning why. But one of the points that I did find out for the change is that one, the grayscale is a luminance, and you're changing that luminance into a color. But one grade of luminance can have multiple colors from RGB in it, and that causes another confliction. So you could have a pale purple and a pale blue could have the same luminance in the grayscale. So that's some of the things that I found out, but it's there as well.
Okay. Tom, is there anything to add, or should stop here because we have the mentoring session?
This was a great class today. I really appreciate the input. Hitesh, excellent. Thank you. It takes courage just to present. So I'm glad you did present. Let's just make sure we get all these materials added to the class repo. So Sadegh, I'm trusting you won't mind us adding your
definitely. I will send it to Reis and maybe, and then he will proceed with that, right?
Yep. And then if we'll get it added to the class repo, and then Jonathan, if you don't mind harvesting the other techniques for class imbalance and adding them to your repo, and we will try to add those to our repo too, but that way that's double findable. Excellent. Okay. Can anyone guess who's showing up at mentoring to visit with us today? Okay, well, prepare to be surprised.
Yeah.
See you soon.
Dennis Rothman?
Huh?
Dennis Rothman?
I don't know who that is.